Alright, this shows the plates coming out of the slit, and the slit is where the extreme atomic white light is. I'm calling it atomic white. That's my new name for that kind of brilliant white. And you see all these plates, and up there you see that purple one, violet. It's much more intense than the rest of it. This is very strange events going on here. Anyway, all the rest of the video will show that. Okay, what I'm about to present to you is some evidence that we have that seems to support wave-particle duality is not real, and it's really particle vortex. And that's a particle spinning in a circular vortex going forward. And it's similar to something like this. All right, now, here's what Rodney's doing on his laser light experiments. I'm going to show you all of these experiments and what they produce. He's doing the traditional slit experiment, but normally they do it with a little piece of black stuff and a tiny little slit. Well, he's doing it with two nails. And what he's done by accident, he's a creative guy. He just did this, playing around, testing, doing this and that. And what I feel he's created here is a Venturi effect, because what happens is it hits here and it's got to squeeze through that little slot. Now, because of the way he made this, the architecture of the nails gives you this circular effect like the wings of an airplane, and it's got to crush itself in a circular manner in here, and they come out of here cascading in incredible pictures, unbelievable. And they come out as plates, and they look like they're quantum plates. And they look like, as they come out, there's an extremely brilliant light, and a brilliant white light, and I believe it's an atomic light, which is the shock of the compression here. And I believe they exceed the speed of light as they come through here, and as they come back into the ambient light, the normal background light that it can only go a certain speed, that's when it creates this what's called Cherenko effect. So now that I said all that stuff, just pay attention to the video, see what you think. You may have to go through it a couple of times. It's a little tricky, but it all makes sense, I think. We really want to know what everybody else thinks, because we don't really have the equipment to test this well. I know they have some really high speed accremeters and this and that and yada yada, and we'd love to have it tested. This, Rodney came up with this idea of, and he just came up with this. It's his idea. Now I have the idea of the particle vortex, and we need somebody to come up and sort of help us out and figure out if we're right. All right? So thank you. Have a good time here. I hope you enjoy the video. Alright, here's another shot, and Rodney's coming from the side, I believe, and there's the atomic shock. And look at what's going on here. Very interesting. That's what we need. We need somebody to help us to understand what we're looking at here. And we've got some ideas, but who knows. Alright, I'm going to have another one about this that's going to have a little more close-up, but look at this. This exact spot here is where the slit is, and we know there's two nails on the other side, and when they come together and they create this Venturi effect, which slams these plates together, and you can actually see the plate being crushed. Now, there's this thing called Pauli principles, which does not allow this kind of crushing, and I believe the effect of that is these atomic shock waves, and that's what I'm saying. I don't know if it's right or not, but when I see this white, I'm going to call that atomic white, because that's above the normal white. Now, I believe anyway. Now, look at the radiation. Whoops. Look at the radiation patterns. Circular radiation patterns all around here. See them? Same thing here. Swish, swish. They're easier to see on this side. But this is what's going on, and I believe that's because of these explosive, concussive shock waves creating unacceptable atomic situations. They can't tolerate this, and as a result, something is being radiated out of there, and I believe it's called Cherenko radiation. And I'll show that later. And anyway, I'm going to show you a close-up on this. Alright, there it is. There's the Cherenko effect, and that's virtually exactly what we're seeing on the other things. And here's the radiation the Cherenko effect creates. And that's because the particles in this atomic white, and that's the color I'm going to call it from now on, when I see this glowing atomic white, those particles have to drop speed because they're hitting a different medium. And when they hit that, they create this atomic shock. And it's like a shock wave of a jet airplane. But there's additional shock values, I think. I'm going to call it shock because you're creating the shock. Well, I'll go into that deeper, but somebody's got to accept this before I can even talk about that. But I'm talking 2 shocks. All right, this is a paper from, I think it's from Princeton Engineering, and it's about atomic shock. And there's spontaneous ignition of pressurized gases of hydrogen and natural gas into air. And those are the atomic gases. Those gases are the energetic gases. And it talks about atomic shock here. And it talks about rapid failure of pressure boundary separation. Hydrogen and air result in multidimensional transient flows involving shock formation, reflection, and interactions such as reactant mixtures that rapidly form, achieve chemical inflammation, ignition, inflammation, and transition to turbulent jet diffusive combustion. And then it goes on and on and on. And it's a huge article, and it's very, very good. And at the bottom here, I'll show you what the conclusion is, which is the important part as far as I'm concerned. Now, at the bottom, it talks about, you don't even need a spark or anything for this stuff. When it hits each other in a compressive, explosive manner, it creates an additional shock. And here's what they're talking about. Pressure boundary failure. Now, the reason they're talking about this is because of the gas industry, to keep gas pipes from blowing up in people's faces. And they're coming up with regulations and so forth. And it hasn't been shown. It hasn't been studied. So anyway, well, it hasn't been studied a lot. Pressure boundary failure geometry, multidimensional shock boundary and shock-shock interactions, in addition to molecular diffusion, can provide the necessary short mixing time scales. Turbulent-free jet hydrogen flames can be stabilized at sufficiently high jet velocities to result in continued combustion. And they go on, that stuff is just so combustive. Hydrogen, unbelievable. And all you got is an electron and a proton there. And there's just, so anyway, they're very, very energetic. Experimental observation identified that the minimum compressed gas pressure related to atmosphere pressure at which spontaneous ignition occurs is dictated by reflected shock and shock-shock interactions. They keep talking about these shocks. And this is atomic shock. This is not just like a little, you hit a drum and you get a shock wave. No, this is deep, deep, deep shock. The repeatable nature, now this is very important, the repeatable nature of the ignition of this characteristic time scale suggests that proposed ignition alternatives, such as electrostatic discharge, sparks when you touch something, are not contributory to the present observations of shock, transient shock, all these shocks. And I believe these shock events create Cherenko radiation. And that's what we filmed, Rodney's photograph. And it goes on and on. Further experiments are needed to quantify, yada, 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 yada. Determine the envelope, design the parameters, why shock induced, and so forth. Anyway, so that's shock, and that's what we're studying, and that's what we seem to have pictures of. All right, my theory says that the particles are spinning in a little vortex, zip, going right down. Now, why would anything spin like that without going off into space? It's staying in that nice tight spin. Well, they call it centripetal force, which is something that draws itself in from a central point. And the only thing that I know of that does that is gravity. And the only thing that, like the center of our solar system is the sun. We all spin around it because of gravity. And everything that's on the earth stays on the earth because of gravity. Things like that. Now, we're into gravity here somewhere for this spinning particle. Something is anchoring the center of the spin. It just literally has to be. in my mind. I could be totally wrong, but I don't see another way of that. And here it is, Newtonian mechanics. Gravity provides a centripetal force responsible for astronomical orbits. I believe we're into the same thing, gravity.